Welcome to the lecture on Risering methods under the Risering design. So, we will discuss about few methods. There are 3 to 4 methods for Risering design, and we will discuss one by one the different design methods or Risering volume calculation methods or shape is anyway fixed. So, size calculation methods. So, first of the method that we will discuss is the Caine's method. So, Caine has developed and gave certain equation for finding the riser volume, and this equation is x equal to a upon y minus b plus c. So, basically he has advocated the relative freezing time of the riser and the casting. So, if the freezing time of the riser, so freezing ratio, it is nothing but the relative freezing time of the riser to the casting. Now, the freezing time is taken as to be proportional to somewhat V by SA, volume by surface area, that we have understood earlier. We have seen that T is normally proportional to V by A square. So, they have taken V by A as a parameter which is indicative of somewhere the freezing time. So, this freezing ratio is nothing but the relative freezing time of the riser to the casting, and that is why this freezing ratio y, this x is the ordinate, this is the volume of riser to volume of casting. So, this is x, x is volume of riser to volume of casting. Now, the freezing ratio, that is y, y is the relative freezing time of the riser to that of the casting. So, it comes out to be surface area of casting to volume of casting divided by surface area of riser to volume of riser. So, this is the parameter. Basically you can have it like this: volume of riser by surface area of riser divided by volume of casting upon surface area of casting, and that is basically the relative freezing rate of that of the riser to that of the casting. And he found that there is a curve which represents this equation. Here A, B and C are constants, and these constant values are having different values for different materials, which is given to in the books, and whenever we calculate for that material we have to use these A, B and C values. Now, what it tells is that once this freezing ratio or the relative freezing time of the riser to the casting, if the freezing time of the riser to the casting, so this is nothing but relative freezing time of riser to casting. So, if you look at this point, as this curve indicates, as this ratio increases, the volume of riser to volume of casting is decreasing. Means if the riser will have such a shape or size, so that it has larger values of freezing time as compared to that of the casting, in that case this value will be larger, and once this value is larger, and if the riser has adequate amount of liquid metal and also it is adequately shaped, it is appropriately shaped, so that it solidifies in a larger time than the casting, in that case the risering requirement, the volume of riser to volume of casting will be basically small. So, smaller size volumes even can suffice that. So, that is the basically essence of his findings, and this way once you develop one equation, then you can solve that equation and get the values of the riser dimensions. For example, suppose you are given with a problem. So, the problem is that you have to find the size of a cylindrical riser to feed a casting of dimension 25 by 25 by 5 centimeter cube, and you have to, you have been given height equal to diameter of cylindrical riser and use Caine's method. So, you are given a plate type of casting which has this rectangular cross section of 25 by 25 centimeter and it has a thickness of 5 centimeter. You need to have a riser, cylindrical shaped riser with height equal to diameter, and that should be able to feed this casting, and you have to calculate using the Caine's method, and you have to do it for steel. So, for steel A is given as 0.1, B is given as 0.03 and C is given as 1. So, this is casting of steel and that is of this particular dimension. So, once you are given, in that case you can solve such problems. So, what you have to do? You have to first find out the volume of casting. Volume of casting will be 25 multiplied by 25 multiplied by 5, and this comes out to be 3125 centimeter cube. Then comes the surface area of the casting. So, surface area of casting will be 2 times 25 into 25 plus 2 into 25 into 5. So, it will be 625 plus 250, that is 875, and this will be 1750 centimeter square. Similarly, volume of riser, that is cylindrical riser with height equal to diameter. So, once you have a cylindrical riser with height equal to d, in that case volume will be pi by 4 d cube. On the other hand, surface area of the riser, now in the surface area of the riser, if you take the side riser and if you assume that the bottom portion does not contribute as the surface which is exposed to the cooling surface or which is exposing the heat or which is radiating the heat, in that case virtually we have the curved surface as well as the top surface. So, in that case the surface area becomes, you have pi d square, pi d is the perimeter and d is the height. So, it will be pi d square plus the top surface area, that is pi by 4 d square. So, that comes out to be 5 pi by 4 d square. Now, after this you are going to have the values of x and y. So, x is nothing but the freezing ratio. So, freezing ratio is nothing but surface area of casting by volume of casting. So, surface area of casting is 1750 upon volume of casting is 3125 divided by surface area of riser upon the volume of riser. So, that will be 5 by 4 pi d square divided by pi by 4 d cube. In fact, this is the freezing ratio which is there on this line. I feel that there is a mistake here. This is basically y, this is the ordinate axis, and this is your x part. So, this x part is the freezing ratio, that is relative freezing time of the riser to the casting. So, x you will calculate from here, and that will be 1750 upon 3125 multiplied by, here this pi and pi will go, this 4 and 4 will go, and d square will go. So, this d will come on the up and 5 will be at the bottom. So, once we calculate this value, it will be 1750 divided by 15625. So, it is 0.112 d. So, this is the value of the ordinate or abscissa, that is ordinate, this x in this equation. Then the y will be V r upon V c. So, volume of riser, that is pi by 4 d cube divided by the volume of casting. So, volume of casting is 3125. So, we have to calculate it. So, it will be 3.14 divided by 12500. So, it will be 0.0000251 and multiplied by d cube. So, this is how you get this value of x and y. Now, we have to substitute these coefficients as well as this value in that equation, and then we can get the value of d. So, if we substitute these values, what we see is x is 0.112 d. So, we have x equal to a by y minus b plus c. So, 0.112 d equal to a is given as 0.1 upon y is 0.000251 d cube minus b is given as 0.03 and plus c 1. So, this way you are getting an equation, you can get further the equation. So, this equation will be, it will be 0.00028128 d to the power 4 minus 0.00. So, this will be 0.112 multiplied by 0.03, that is 0.00336 d. So, that will go that side and you will have 0.1 plus 0.000251 d cube minus 0.03. So, this way you are basically finding one equation which has the d to the power 4 terms, d raised to the power 3 terms, all that, and this can be further simplified, and you have to basically solve this equation by using the trial and error method. And once you use that, by using trial and error method, if you find the solution of this equation, you get the value of d somewhere close to 12 centimeter. So, for that basically you will have to solve this equation, which is certainly somewhat cumbersome to solve. It will take a lot of time, little bit, and then you can get the value. From this graph also, if you can just assure yourself, if you know the casting dimension, if you know the dimension of the riser, in that case what you see is, if the freezing ratio you have calculated, and if it falls somewhere, if you get this volume of riser to volume of casting, and if you are getting this particular point which you get in this part of the casting, then you can assure that your casting will be sound and there will not be any defect related to shrinkage. However, if that point lies below this line, the line which is supplied, if the point lies below this line in this zone, in that case it will be having the shrinkage problem. There is probability of having shrinkage in such cases. So, this is the method of solving this Caine's equation and getting the riser sizes. Next method of calculating the riser size is the modulus method. Now, what do you mean by modulus? So, in the earlier method, in the Caine's method, what we have seen is that you have to find the surface area by volume of casting to surface area by volume of riser. That ratio will be working as a value on the x axis, and then volume of riser to volume of casting will be in the y axis, and then you can have solve this equation and get the value of the dimension of riser. Now, another method is modulus method. So, what is modulus? Now, to get rid of such cumbersome equations and solving them, another method which has been proposed by Lodauer So, he has proposed that the modulus of casting, so modulus is defined as volume upon cooling surface area. Now, the volume upon cooling surface area is certainly related to the freezing time. The volume upon cooling surface area has only been taken by Caine also, but he has modified it and he has simplified it. What he has suggested, what this method has suggested, that if the modulus of casting and modulus of riser is calculated, certainly for the casting to have no shrinkage defects, the modulus of casting must be less than the modulus of the riser, or in other words, modulus of the riser must be more than the modulus of the casting. So, for avoiding any shrinkage related defects, modulus of riser should be more than modulus of casting. So, it was suggested that it has to be more, and a typical value of 1.2 was seen to be satisfactory, and they told that modulus of riser should be somewhere near to 1.2 times the modulus of casting. So, if the modulus of this riser is 1.2 times the modulus of casting, in that case the casting can be sound. Now, if you take for a cylindrical riser, where what we have seen in the earlier case, where we take a side riser with only one top surface to be the one which is taking part in extracting the heat. In that case, if you take modulus of that riser, so it will be volume of riser upon volume of or cooling surface area of riser. So, volume of riser is pi by 4 d cube. We are taking height equal to diameter. If we take the riser with height equal to diameter, in that case volume of riser will be pi by 4 d cube, and cooling surface area of the riser will be pi d square, that is the curved surface area, plus pi by 4 d square, that is one of the top surface of the riser which is extracting the heat. So, it will be d upon 5. So, it will be pi by 4 d cube and it will be 5 pi by 4 d square. So, this d will remain here and 5 will be remaining here. So, d upon 5. Now, if you put this condition in this case, in that case the modulus of riser comes out to be d by 5. So, d by 5 should be equal to 1.2 times modulus of casting m subscript c, and from there what you get is d will be equal to 6 times modulus of casting. So, it becomes very simple to calculate the diameter of the riser, which for which you have to simply multiply the modulus of casting with 6. So, once you have a casting given, you find its modulus, multiply it simply with 6, that will give you the diameter of a cylindrical riser whose height and diameter are same, and you are basically avoiding all sort of problems which you had to do regarding the computation of the diameter in the case of Caine's. So, it becomes very simple. Now, this modulus how to calculate? We know that modulus is volume by cooling surface area. So, if you try to calculate the modulus of different shapes or sizes, you can calculate it. So, we will see how to calculate the different shapes of, the modulus for different shapes of the casting, like spherical, cylindrical, cubical, or different plates and bars and so. So, let us find how to find the modulus of different geometries, modulus of different shapes. So, if you look at the modulus of spherical shape, spherical dia d. So, for this what you get is the volume is 4 by 3 pi r cube. So, pi into d by 2 cube upon 4 pi r square. So, it will be 4 pi d by 2 square. So, it will be 4 and 4 getting cancelled. So, d by 2 cube. So, d cube upon 8 into 3 multiplied by d square and into multiplied by 4. So, it will be d upon 6. So, for a spherical shape you get the modulus as d upon 6. Similarly, for a cylinder with h equal to d, and you assume that both the surfaces suppose are acting as the surface which expose the heat. In that case, the volume will be pi by 4 d cube and surface area will be pi d square, the curved surface area, plus pi by 4 d square on the top and pi by 4 d square on the bottom. So, it will be pi by 2 d square. So, it will be pi by 4 d cube upon 3 pi by 2 d square. So, it is 6 pi by 4 d square. So, it will be d by 6. What we see is for a spherical casting of diameter d, the modulus is d by 6. For a cylindrical casting of height equal to d with both its flat surfaces actively engaged in extracting the heat, in that case it becomes d by 6. It will be different if we do not take one of the surface. So, it will be different. Then in the case of suppose cube, in the cube if side is taken as d, so in that case the volume becomes d cube and the surface area total becomes d square. You have 6 faces, every face has the area of d square. So, then it also becomes d by 6. This way you can calculate the different value of the modulus for different geometries. Similarly, for a plate with dimension A as length, B as width and T as thickness and A is less than 5 T, in those cases it is calculated out to be 0.5 T. Similarly, a bar cross section AB, cross sectional area is AB and this is a bar, in that case it comes out to be AB upon 2 into A plus B. You may calculate this value of modulus for different shapes, even for hollow shapes, by using this formula volume upon cooling surface area. So, this is how you calculate the different volumes. These volumes are directly used to calculate the diameter of the cylindrical riser, and basically it is a simple method for calculating the riser dimension. Thank you.